Hello everyone. Let's demonstrate the RAG optimization feature with the GEPA. Recently we merged this giant pull request to enable the RAG optimization. This basically adds a RAG adapter. So at the moment you can optimize your prompts with GEPA, but if you have a RAG systems, so we now have a new adapter for RAG, and in the GEPA you can see some examples. So at the moment we support 5 vector database: ChromaDB, LaunchDB, Milvus, Qtrent, VVet. Follow that documentation on your own time. Before that, let's have a quick look at this script and see how you can use this script in your workflow. So what we're doing in this script basically is we installing your vector database. For demonstration, we are doing for everything, but you probably need one of them. Then we're creating the LLM client. So LLM client can be for the task LLM as well as the reflection LLM. Then we're using the embedding function. So at the moment we're using the local embedding models in the script. And then we have setup for different vector store. So you can see there's a setup for all vector store. And after that we have documents for the RAG. And then we create a training data. As you can see, we have like a limited set of training and validation data. We just have 3 examples for the training data and 2 examples for the validation data. And then clean answer and the initial prompt. And then we set up the script to run for each vector store or your preferred model, so that you can pass on the command line. This default script will use Qwen 3 8 billion model by default, both for the task LM and the reflection LM. But you can obviously change this using this the RAG adapter. You can pass different LLM client, or the GEPA optimization, you can pass different client edition. So I already have a GEPA project out here, and obviously I have a script. So I made a slight modification to the script. In this script, what I'm doing basically, I'm using GPT-oss 20 billion as a task LM and GPT 120 billion for action LLM. So I made this modification in my machine. So you can see this, I'm passing this reflection LLM, and then for the RAG adapter, as you can see, my reflection LLM is this one, and my default one, GPT-oss 20 billion. So now let's run this optimization, see how they perform. So before that, I have the Ollama models already downloaded, and the GPT-oss 120 billion is already running on my machine. For VVet optimization, you probably need the container to start. So now let's run this one by one for different vector databases. Let's start with the ChromaDB first, and let's pass the 10 iterations. As you can see now, setting up the things using this GPT-oss 20 billion as a task model and running the optimization. As you can see, the optimization might take some time. As you can see, the optimization is finished. The GEPA has finished the 10 iterations, and we have a little bit of improvement in the score. So now let's switch it to the LaunchDB. Now it will use the LaunchDB vector store and basically doing the same thing for the LaunchDB vector store. So as you can see, the optimization has started now. So GEPA is now performing iterations. As you can see, there's some core instructions has been printed, and now it is finished optimization, and you can see the slight improvement in the score as well. So let's move on to the next one. Let's try with the Qtrent. So we started optimization again. Okay, after some time, it reached to the same point where it's printing the core instruction. As you can see, it's finished now, and you can see some slight improvement in the score as well. Now let's try with the Milvus. you can see it's progressing now. Okay, it's almost finishing for the Milvus. I don't know why it's taking crazy long time for the Milvus, but we can still see the very, very slight improvement. And finally, let's do with a VVet. And remember, for the VVet, you need to have this Docker container running, one of the prerequisites for the VVet. And he's obviously going to do the same thing, performing the iterations. Now you can see the VVet optimization also finished. So you can try the same setup on your local machine if you want. And if you have any questions, just drop a comment below.